Sorry. Yeah, so EMS is responsible for doing the functional configurations of the virtual net VNF. That is, we need to tell how many core this VNF is going to use, its memory requirement, number of instances that we might need, etc., etc. Okay, and VNF manager's major function is to take care of the life cycle of each VNF. That is, when do we need to bring up the VM? How many instances we need to bring it up? When do we need to update the? It's all softwares, right? So when do we need to update it? When do we need to bring it down? All these are taken care by the VNF manager. Then VIM is majorly interacts with the NFVI, and it takes care of handling the virtualized part of the compute storage and network, handling in a more how much of the virtual software, virtual compute, virtual storage and virtual network is needed, that is taken care by the VIM. So how much is needed, that much, that handling is taken care by the VIM. Then the NFV orchestrator takes care of the completely automating the whole process, like takes care of automating the whole virtual network functions on the particular infrastructure. That is the job of the NFV. I mean, sorry, the orchestrator. So this is the overall architecture. Then now, as I said, there are positives. There are negatives also associated with network function virtualization. One of the major difficulty, or okay, one another thing that I must to talk about is the deployment option. So as I told, we can deploy the deployment options are majorly one is using VMs. As I just showed you, we can spin up a VM and run the network function inside the VM. Another is using containers. Then another one is using unikernels, and the other is with bare metal servers. Then the challenges with NFVs majorly is that one is majorly with respect to the performance actually. So we have seen that we are moving the middle box functionalities. We are moving the functionality from hardware to software, right? So when we move a functionality from hardware to software, will the speed increase or decrease? Performance will improve or come down? Any idea? So in general, hardwares are considered faster, right? So when we move the functionality from hardware to software, it of course the software will not be able to process at the rate at which the hardware performs. So there will definitely be a degradation in the rate at which the packets are processed. So there is performance and scalability issues when we comes to like performance and scalability. What I mean is when the number of the with high data rate and all, the so what a middle box hardware can provide is like if the hardware is providing the throughput in the range of 320 to 640 Gbps for firewall, and this is for CGNAT. What a typical software can provide is like 10 to 40 Gbps. So this is the rate at which is when we run in the software, one can achieve. The same way, the number of connections per second that with the software one can handle is less than 1 million. Whereas with middle boxes, it could be as high as 500 millions. Same way, the availability hardwares are like available 99.999, whereas here the availability is 99.9. So these are certain challenges with respect to the NFE. That is, standard servers are more prone to hardware and software failures compared to the hardware devices. Prone to hardware and software failures than commodity hardwares. Then the rate at which the packet processing can happen is also limited. So to enhance the performance, when we are working in the with NFV, how one can improve the performance. So when we look at the way the NFV work, so as we saw, there is a hypervisor layer. So there is one underlying host OS. Then there is hypervisor, and there is the VM. And in the VM, typically, if we consider it like this, typically, if the NFV is running in the VM, then when a packet comes, typically it traverses the host stack via the hypervisor, and then it goes and traverses the VM stack. So in normal commodity off-the-shelf hardware, typically we deploy the Linux kernel, and one of the major bottlenecks that is observed is the Linux TCP/IP stack. That is observed as TCP/IP stack. So typically, when a packet receives at the NIC, when a packet is received at the NIC, there is this entire TCP/IP stack that is running in the kernel space, and then in the user space the application will be running. So from all the way from here it has to go to here, then it traverses, then there is a copy, and then it reaches the application. So NIC to, when a packet receives at the NIC to kernel space packet copying happens via DMA, and then from the kernel space there is again a copy to the socket buffer. So this whole part is considered slow, and this is the major bottleneck when we try to do this kind of high speed processing. So there are techniques that have been proposed, such as DPDK, PF ring, etc. So DPDK is typically a data plane development kit, wherein they try to bypass the kernel, so as to reduce the bottleneck. So as I've told, this is the major part where the bottleneck is there, right? So in DPDK, how they try to do is you receive it with the NIC, then directly DMA it here, and then the application receives. So this whole part is bypassed. The whole kernel stack is not processed. Instead, the layer 3 and layer 4 processing must be done in the user space. So this is one approach that is used to increase the packet processing rate. Another one is used to have NIC with the offloading a lot of functionality onto the NICs. Then there is user mode packet processing called PF ring. These are certain things attempted. So yeah, I think we can now take a look at the previous year question papers. Yeah. Well, I'll read out the question, and if needed, I can use this. Yeah. So the first question is, which of the following challenges is associated with the NFP? Challenges of NSP. So one is increased network complexity and management overhead. There is reduced flexibility and scalability. Lower security and privacy. And third is higher cost. So what do you think could be? So just go through this once. Which of the following challenges is associated with network function virtualization? Increased network complexity and management overhead, reduced flexibility and scalability. Third one is lower, one, two, three, four, lower security and privacy, and last one is higher cost. Which one do you think is the answer? You can respond in the chat, then we can discuss. Anyone? So higher cost, does NFC virtualization have higher cost? Yes or no? Function virtualization increases the cost or decreases the cost? No, so it doesn't increase the cost. In fact, we are able to decrease the cost. So this is not the answer. Lower security and privacy. We are running the NFVs on virtual machines which provide isolation, and even in if we are running it in as containers that also provide isolation. So the orchestrators take care of isolation and privacy between the tenants. So this is also not true. Does it adds flexibility and scalability, or it reduces flexibility and scalability? Yeah, so it adds, so provides flexibility. And here, when we say scalability, when we need to spin up more instances of the virtual function, so that is very quicker than buying a new hardware. Like if I want to have a new instance of NAT, we can quickly instantiate that with NFV, but procuring a new NAT device might take time. So with that flexibility and scalability, it increases. So increase network complexity, management overhead. This is actually true. So if you see in place of a simple like having a router like this and having a middle box and a router like this, we have reached the above diagram. From this we have reached here, right? So this is more complex, needs a lot of orchestration and management, but it is, since it is in software, we can automate a lot of things. So but yes, management is needed. It have increased the complexity, but it's not to the extent that it cannot be dealt at, because it's in the software, a lot of automation can be brought in. but it do increase the complexity and the management overhead. So the answer is 1. The next question is, what does bump in the wire model mean? So a disconnected network for middle boxes. 2. Different kinds of wire to connect middle boxes. Traditional model of connecting the switches, routers, and the middle boxes connected to routers per switches. Switches and routers, RTRs, increase packet delay. Estimation. Yeah, please take a look at this question and then we can discuss. Yeah, anybody else? You can type in the answer. So bump in the wire means that we have 2 routers. In between, you just add the middle box like this. Okay. So this is like bump in the wire. It is going. Go. Doesn't mean that it bypass. Okay. It goes here. So what bump in the wire means? There is a small so it was going like this. Here there is a delay and then it goes. The packet is going. There is this delay added and then it is again going on the wire. Okay. So a disconnected network for middle box, no, that is wrong. It's connected only. Different kinds of wire to connect middle boxes, no. The regular wires that we connect, it doesn't mean that there is a different wire. Bump in the wire doesn't mean that. Then traditional model of connecting the switches and router, no. Bump in the wire, traditional model of connecting means like this. There is nothing in the middle. Two routers are directly connected. So this is what bump in the wire means. So from destination to source or source to destination, as the packet travels, there is a delay added for it. So the next question. Okay, I will paste the question in the chat. So what layers of operation does NFV address? So we know, right, the Layer, we have layer 7, no? Physical layer, link layer, IP layer, transport, and then application layer. So of this, what layers of operation does the NFA address? So typically, NFA functions address the IP layer, work at the IP layer, transport layer, and the application layer. Okay, and that's where the middle boxes work, right? So network layer, transport layer, and application layer. So the answer is D. Next question. Yeah. What is network function virtualization? Is it a protocol used for wireless communication between two devices, or is it a technology that virtualizes network functions into software? A technique used to encrypt network traffic for security purposes, a technology responsible for monitoring network packet. So it's not NFV is not a technique used for encrypting. It's not a technology responsible for network monitoring network traffic, and it's also not a protocol used for wireless communication. So NFV is nothing but a technology that virtualizes network functions into software. So the answer is B. The next question. What is the difference between network function virtualization and software defined networking? Go through the options and then comment. All right. So the first option is NFV is focused on separating the controller and data plane in a network, while SDN is focused on virtualizing network functions. So what is SDN? SDN is nothing but separating, decoupling control plane and data plane, right? Decoupling control plane and data plane. So we had a router with both CP and DP here. With SDN, we have the controller here, and then we only have the data plane, right? So this is the concept of, this is the open flow southbound interface. This is what SDN does. So option A is wrong. NFV, whereas what does NFV do? NFV, we had a box, we are converting it to software. So that is what NFV does. So NFV is focused on virtualizing network function. We had a network function inside, we are making it a software. Virtualizing network functions, while SDN focuses on separating control plane and the data plane in the network. So that is correct. NFV and SDN are the same thing. NFV is a hardware based approach, while SDN that is also wrong. So the correct answer here is B. NFV is focused on virtualizing network functions, while SDN is focused on separating the control and the data plane in a network. Okay, so the answer is B here. Next question. Hmm. Yeah, go through the question, then we can discuss. Okay, option D is not complete. Paste it again. Okay. So, which of the following statement is or are correct about network function virtualization? So the question it is asking which of the statements are correct. Okay. So NFV eliminates the need for hardware changes when network requirements change. Yes, that is true. So there is no longer any hardware dependency, right? So we don't need to make any hardware changes. So A is correct. The role of a virtual network function in NFV is to centralize network control in a virtual environment. No, the role of NSV is only to softwareize or virtualize the network function. It is not to centralize the network control. Okay. So B is wrong. C is, so A is correct. B is wrong. C is network functions virtualization is the ability to run multiple virtualized network functions on a single hardware server. Yes. So we have already seen, right, here. So this is on a commodity hardware, we can run multiple VNFs. So it allows us to run multiple network functions on a single hardware server. So C is also correct. Now D, virtual network function enable network operators to implement network functions using dedicated hardware device. No, the whole intention of VNF was to get away with dedicated hardware device. So D is wrong. So the intention of VNF was to get away with or remove dedicated hardwares. So D is also not correct. So the answer is A and C. Next question. Hmm. So, which of the following is not a primary function of the operation support system? Yeah, so here fault management. So from an operator's perspective, fault management, configuration management, and performance management are what the operator is concerned about, not the customer management. So the answer here is C. Okay, C is not the primary function of operations support system, whereas the others are. The next question. Which of the following statements is bar are correct? Is bar are incorrect. Okay, so we should point the incorrect statement. So the first statement is a virtualized infrastructure manager (VIM) is a part of the NFV management and orchestration layer. So VIM is part of the, where is the, so VIM, so this is the MANO. This whole box is MANO. So virtualized infrastructure management, VIM, it is part of MANO. So option 1 is correct. But what they are asking is which of the options are incorrect. The NFV management and orchestration layer is responsible for managing the physical network devices. No. So Mano is not responsible for managing the physical network device, only the virtualized part it is responsible. So B is wrong. The NFV infrastructure manager is responsible for providing physical resources for the virtualized network function. So NFVI. So this forms the whole infrastructure. So this NFVI is responsible for providing the resources for the virtualized network function which is running on top of it. So NFVI is responsible. So C is correct. Now the management and orchestration layer is responsible for providing the virtualization layer in NFV architecture. No, this virtualization layer is also not part of Mano. So D is also wrong. So B and D is wrong. A and C is correct. Okay, so the answer here is B and D. So next question. Which network functions virtualization component is responsible for automated provisioning of virtual network function? Yeah, so the automated provisioning and is taken care by the NFV orchestrator. So it is the function of the NFV orchestrator to completely do the automated provisioning. Complete provisioning is taken care by the NFV orchestrator. So the answer here is D. Answer is D. And this is the last question. Which network functions virtualization component is responsible for managing the life cycle of virtual network functions, VNF? Operation support system, virtualized service manager, VNF manager, and virtualized infrastructure management. So of this VNF manager is actually responsible for the life cycle, managing the life cycle of the VNF, that is when to instantiate it, when to do the updation, when to terminate it. So yeah, so this is VNF manager is responsible for VNF manager is responsible for taking care of life cycle of the VNF. Yeah. So actually you can go through this part where the components are explained by the professor, and then I think all of the you will get all the answers from there. Yeah, so these were the questions from last year. So if no longer, so I'm done with the session. If you have any doubts or if you want any specific part to be discussed, we can look at it. So just tell me how many of you have used these virtual machines? How many of you are aware of the concepts of containers? Are you aware or at least the concept of virtual machine is clear?
I'm partially aware. Have installed Kali Linux on VMware
Okay, okay,
once,
okay. Yeah, okay.
but not much in detail explored it. How the network, how
Yeah.
they work. Yeah.
Okay. So, I mean, that would help understand the concept of virtualization. Like, at least you'll be able to visualize when we tell that, okay, we run the network function on top of, like, we run multiple VMs on top of a single server. At least if we have used the VM, virtual machine at least once, it's the same concept that's replicated there also. So, that will help understand better. So the major difference with virtual machines and containers is that in virtual machine, I think I just told you that we have something called as host OS operating system. So in my case, I just showed that I have a Windows laptop. On top of that, my hypervisor is VirtualBox. So we have the hypervisor, And using the hypervisor, we can run. Uh, then on top of that, we can run multiple virtual machines, VM1, VM2, VM3, etc. So all these VM machines or virtual machines will have a full-blown operating system installed in it. So if it is an Ubuntu 22, you will have the Ubuntu 22 installed in it. If it is a Windows machine, it will have the operating system installed in. So this also will have the operating system, the kernel, everything will be there. It's a full blown kind of a system, full blown operating system, full blown machine. Whereas in containers, we use a different concept. So we have the host operating system. So containers, and there will be, so we have the operating system, host OS. So containers run on top of the host operating system. So if it could be container 1, container 2, container 3, and they use the same operating system, and it's run as an instance in the same so it's much smaller. So containers are like so they are run like a process on on the system. So they are like we will have the containerization agent will be there, like Docker, etc. So these containers are run like a process in the particular host operating system. So this they don't have any full-blown operating system here. So when you see the size also, containers would be much smaller in size, very fast. So if you have noticed, when I was trying to boot up my VM, it actually took a lot of time. But containers just spin up very quickly because they are very lightweight in that way.
Madam,
Yeah.
VirtualBox or VMware, these are examples of virtual machines. So examples of containers.
They are examples of hypervisors that facilitate VMs.
Okay.
Yeah. So for containers, we have Docker.
Okay.
Docker is something that I am aware of at present. There are other containerization tools also, but
So
aware.
basically, that also we use for the same purpose, like installing a different OS on this.
No, no, no. When you're deploying it in a like the NFVs, network functions, VNFs, virtualized network functions, we can deploy it either on VMs or as containers. So when we deploy them in a virtual machine, it will be in a different way. When we deploy, the deployment steps will be different.
Okay.
But finally, the functionality that they provide will be the same.
Okay.
Any other doubts or queries? If not, then I think we can close the session. Thank you. Thank you for joining the session. We'll have the next week 8 interactive session next Friday, same time. Thank you. See you next week. Thank you. Bye bye.